Hello, I'm Matt Galloway, and this is the Current Podcast. The search for life in outer space has led astronomers to look everywhere, from the surface of the moon to distant planets light years away. We have not found any aliens yet, at least officially, as far as we know. But recently, scientists discovered a bacteria that has never been seen on Earth, living inside a Chinese space station. This mysterious bacteria has evolved special abilities that can help it survive in the extreme conditions of space. Jamie Foster is a professor in the Department of Microbiology and Cell Science at the University of Florida. Jamie, good morning.
Good morning.
What exactly is this new mysterious bacteria?
Well, it's actually, this type of bacterium is kind of close relatives are found in the soil. They can be found in water and sewer systems. So it's not a complete alien. We recognize it as being closely related to microbes that we find very commonly on Earth.
Tell me more about that and what it might be comparable to here.
Well, it's if you've ever heard of an organism called bacillus. Bacillus form these spore-like structures that are in the soil, they're in water, and they have a tendency to form biofilms and can grow under very extreme environments. And so that's probably why this microbe became more adapted to living in the space station.
So you said it's not a complete alien. Tell me more about why you use that phrase.
Well, I just want people to not realize that it's DNA based. You know, it's a cousin to another microbe that probably started here on Earth and hitched a ride up on the rocket to the space station, or hitched a ride on a piece of equipment. So when I say that, that means that it evolved, it changed. The extreme environment of living in space probably caused the microbe to adapt in a way that was completely novel and to survive in that extreme environment. And that resulted over time in a new organism. That's evolution at work.
So that's important. I mean, it's not something that is from space. It's something that we believe came from here and then changed when it got to outer space.
Absolutely. Just because it's so closely related to, in terms of its DNA genome sequence, it's very closely related to microbes that we find on Earth.
How was it discovered? I said it was inside the Chinese space station?
Right. So what astronauts do, whether it's the Chinese space station or the International Space Station, is they're constantly monitoring the environment. And so in this particular case, they did a regular swab. Maybe they were checking a piece of equipment, but it's kind of normal procedure to keep track of the microbiome that's growing inside these spacecraft. So a few years ago, they took a swab, and then when they analyzed it to see who's there, they kind of realized this has a novel capability that we've never seen before.
And is that common, that things in those environments would be found that would surprise scientists?
Yes, I think it happens a lot more than we realize, that when you put a microbe that's in a completely novel environment, that's never seen that environment before, it kind of expresses a lot of different genes. It's kind of opening its genetic toolkit to say, how am I going to adapt in this particular environment? So in the case of this bug or microbe, it actually turned on a gene that helped it grow or feed on a gelatin. And that probably helped it feed on this extreme remote nutrient limiting environment.
Tell me more about that, because the environment of space, I mean, even if it's inside a space station, is obviously extreme and incredibly hostile. And so what would it need to do to be able to survive?
Right. So it's experiencing microgravity. All organisms on life we have gravity. So this is completely novel that it doesn't have gravity to kind of orientate itself. Even a microbe is getting cues from its environment. And then it might be experiencing more radiation that might have to deal with more oxygen stress. So it's experiencing all these different new environmental perturbations. And so in order to respond to that new environment, it's got to figure out quickly how it can turn on a particular gene or a protein to let it thrive in that environment. So now we're not talking minutes. This probably happened over months, maybe even years, that this microbe was up there, and they just happened to catch it a couple years ago. So even though microbes can respond really quickly, like on the scale of minutes, this probably took at least a few months in order for the microbe to slowly adapt and become successful in growing in this environment.
It has a couple of things that I'd read that allow it to survive in that environment. One is because of the radiation from the sun, it has some sort of protection from that radiation. Is that right?
In this particular bug, I think it's more that they're better at fixing mistakes.
Okay.
So you're absolutely right that not only are they they don't have to deal with solar radiation because they're protected by the spacecraft. But when they are, especially when we're going to go to Moon or Mars, we're going to leave the protective magnetosphere that keeps every living organism on Earth safe. And when that happens, they're going to get exposed to a lot more dangerous radiation like cosmic radiation and galactic radiation. But on that spacecraft, they're not really dealing so much with solar radiation or ultraviolet lights, but they might be getting a little bit more higher levels of cosmic radiation. And so they could be just better at fixing the mistakes, unlike other organisms humans that we're not so good at fixing breakages in our DNA.
And it regenerates very quickly, is that right?
Well, it's a possibility that this organism has adapted and allowed itself to respond more quickly to an oxidative stressful environment or a radiation stressful environment and repair itself. I think on this particular organism, they still need to do a lot more work to understand how that microbe was able to thrive a little bit better in that environment.
Should we be at all concerned? I mean, you said it's not entirely alien, but this thing goes up, it changes while it's there, that it could impact us, and it might be bad news for us when it comes back down to Earth?
Absolutely. I mean, there's good and there's bad with this. The good is that they're monitoring their environment. They're keeping track of what microbes are present. They're kind of taking inventory of the microbiome of the spacecraft. And that's a lesson that NASA has learned, on the International Space Station. And now commercial stations, as new space stations are being built literally as we speak. That's a lesson we have to keep monitoring the microbial environment so that we know what are the good guys there that are going to help us thrive in that environment and what are the opportunistic pathogens that might cause problems. So the discovery here just shows how vigilant we have to be in maintaining an awareness of our microbial community around us. But it could also lead to new discoveries that we can take that new microbe and put it to work and maybe engineer it to make things for us because we know it's now more resilient to that space environment. So there's good and there's potential bad that we need to keep track of.
Things that when you say make things for us, I mean things that we might learn because it is able to thrive in that extreme environment.
Exactly. It's already adapted to that environment. And if we can use genetic engineering, we can kind of have that microbe synthesize products that we might need for a long duration mission. So that's a whole area of research that people are looking at is how can we make microbes to work for us and make products so we don't have to take everything in the pharmacy or take everything with us. We can just kind of make things on demand. So that's kind of a future area of research, but these discoveries kind of help lay the foundation for that work.
Can I ask you said about vigilance. I mean, this was discovered on the Chinese space station. It's not as though everybody's heading up to space, but there are more people who are heading into, he said in quotation marks, space than ever before, right? We need space tourism and what have you.
Right.
Do we need to think about that in terms of what those spacecrafts might be bringing back to Earth?
Well, I think in the case of things like Blue Origin, where they're going up, for only 10 minutes, there's two issues. One is you're absolutely right. We have to stay vigilant because more and more people are going to space with more and more types of bodies and more types of health states. So they may not be the perfect physical specimen that NASA or the Chinese, I'm sure, select for. So we might have a wider range of people responding to different environments and that we do have to stay vigilant. But I also think that we don't have to worry so much because especially on the Blue Origin missions where you're going up just for a few minutes, I'm sure that there's more opportunity to clean the spacecraft. There's more opportunity to, have intervention there. So I think as a space tourist, if that's something you're really excited about doing, you should go for it. Don't worry about the microbes because it'll be an amazing experience. But for the scientists, I think we constantly have to evaluate, where we are with the exploration of space.
What to you is most interesting about the story?
I think it's just another piece of evidence in that we humans, we take microbes, we're walking petri dishes. Everywhere we go, microbes are coming with us. Whether we go to the moon, whether we go to Mars, microbes are coming with us, and we just need to stay open to the idea that microbes are coming with us on this trip, and we have to keep an eye on what's happening to them. They also are responding to the space environment. It's not just us. And so keeping track of how they're changing in that environment, and can we leverage those changes to make things for us, make new pharmaceuticals for us, therapeutics. So that's exciting to me, that this could be a stepping stone in our next step of exploration. And we just have to keep an eye on them.
This is so interesting. Jamie Foster, I'm glad to talk to you about this. Thank you.
Thank you.
This has been The Current Podcast. You can hear our show Monday to Friday on CBC Radio 1 at 8:30 a.m. in all time zones. Or you can also listen online at cbc.ca/thecurrent or on the CBC Listen app or wherever you get your podcasts. My name is Matt Galloway. Thanks for listening.